Hi everyone, for our project, we're trying to predict the COVID-19 cases, such as confirm and deaths based on one's diet and input of food. Next slide, please. We want to do this because we believe a healthy diet is very important to prevent and recover from various infections, and keeping a healthy immune system is a must in our current situation. So through our project, we're trying to get some new insights into the importance of nutrition and eating habits and how it's going to influence one's probability of getting COVID. Next slide, please. To do that, we have 5,130 columns in total as our data set. And each column represents some fat intake or food intake of different types of food, as you can see on the picture on the right here, as well as some COVID data, such as confirmed, active, deaths, and recovered, and so on. Next slide, please.
First of all, we wanted to do some visualizations to help us understand the data set. We made heat maps for each data set to show the correlation between every single variable. These are the heat maps we made, and the darker the blue color, a closer correlation is represented. We then print out the top 12 variables related to confirm and see these as the results. It is to be mentioned here that recovered cases and active cases variables are dropped, since they are not the center of a study here. If the relevant variables for death cases are printed, we see the same results as confirm. This suggests a direct relationships between confirm and death, and this is also suggested by this diagram. Recalling the results for top 12 variables related to confirm, we will find out that animal products, vegetable products, obesity, and milk have occupied the top 6 relevant variables for all 4 datasets. If we plot these variables against confirm, we see that for high confirm countries, they tend to have above average obesity, milk, and animal products. Also, low confirm countries tend to have above average vegetable products. This suggests a correlation between these variables and confirm. For pre-processing, we first fix the missing values in the dataset by using KN to predict these values. As for countries without information on record of COVID-19 cases, we deleted them. Additionally, we found out that many of the undernourished column is marked as less than 2.5 instead of a numeric value. Therefore, we replace these values with 2.4. Then we drop the variables country, active, and recovered because countries is unique and the other 2 variables are not the center of what we are predicting. We also dropped confirm death variables because they are the ones being predicted. Then we concatenated top 12 variables relating to confirm and from the 4 datasets and split it with the ratio of 1:4, which is 20% for test set.
And now I'm going to talk about the models that we had. The first model that we have is linear regression, and we evaluated the model using MAE, MSE, RMSE, and R2 score, and the results are shown below here. Next slide, please. We also tried lasso, considering that we have a large number of attributes within our data set, and some of the coefficients from linear regression model is very close to 0. And evaluating based on our MSE and variance score, we do see there is an improvement using lasso compared with linear regression. Next slide, please. Next model that we use is KNN. And here are 2 plots which shows the relationship between the number of K and RMSE. And we choose K equals 12 using RMSE as a standard. And also we show the MSE and MAE for the KN models when K equals 12 here. Next slide, please. The last model that we choose is random forest, where we use randomized search cross-validation to find the best parameters. The best parameters are shown here below, and we also evaluate the model using MSE, MAE, and RMSE. Next slide, please. To evaluate and compare those models that we choose, we mainly focus on RMSE and MSE to determine if the model is overfitting or not. And as a result, KNN and in detail, when K equals 12 overall has a better performance compared with linear regression and random forest.
In conclusion, we think that visualization suggests that high obesity, animal products, and milk affects COVID-19 contraction. This encourages that although no scientific evidences have shown these as causes of high contraction rate, it helps to keep a healthier and stronger immune system. And for the models, KN provides the best performance among the 3 models we chose. And these are some of the questions that we might go on to discover for our next step. And these are the references we used. Thank you.